Alright, hey guys, how are you doing today? This is a re-recording of my video on the area of composite figures since the first one did not have any sound. So, here we go. Alright, we're trying to find the area of a composite figure. But before we can do that, we need to know what a composite figure actually is. And a simple informal definition of a composite figure is just this weird looking shape that can be broken down into different shapes that might make finding the area easier. So, a composite figure is a figure that can be separated into regions that are basic plane figures. So, it can be separated into regions. So, basically, so say we have a square with a triangle on top of it, and together they form this composite figure. If you can separate it into a triangle and a square that makes it up, you can find the area of the triangle and the area of the square, and that'll give you the area of our composite figure by adding up those two areas. And that's what we say in our second bullet. To find the area of a composite figure, we want to divide up the regions and find each area, then find the sum of the areas. Okay? So, I think it might be a little bit easier if we just do an example. So look at number 1. Our directions say to find the area of each figure and then round to the nearest hundredth when necessary, meaning 2 decimal places. So if we look at this figure right here, this composite figure, I have 2 different shapes split up by the dotted line. The top shape is, of course, a rectangle. It will have an area called A sub R. R for rectangle. And then the bottom shape, we have a trapezoid. We'll call that area A sub T for trapezoid. So, to find the area of the rectangle, what do? We need the length and the width. I have a length of 12 and a width of 23. So the area of my rectangle will be 12 times 23. And that gives me an AR of 276 centimeters squared. Remember, all areas have squared units. And now for our trapezoid, using the formula for area of a trapezoid, we plug in what we have. Okay? So, I know for a trapezoid I need the height, which is the perpendicular distance from between the 2 bases. To find this distance right here, the height, I can take the total height of the composite figure, which is 18, and subtract the height of the rectangle. So 18 minus 12 will give me that this is 6 centimeters. So, using the area of the trapezoid, I have 1/2 times the height of 6 times the sum of both bases. This is 23 centimeters, since that is a rectangle, and opposite sides of a rectangle are congruent. So my equation is 1/2 23 times 6 times 23 plus 15. Plugging that into my calculator, I get 114 centimeters squared. So my whole composite area, which I'll just leave as A for area, is equal to 276 plus 114 for a total of 390 centimeters squared. And that's that. I will do one more of these examples with you, but hey guys, so here's the deal. I will help you set up how to find the areas for some of these, but I'm not going to work every example for you to keep the video somewhat short. But what I will do is I'll tell you what shapes that we have here. Okay, so number 2. I notice that this is a half circle, and then I have another half circle, and 2 halves form a whole circle. So technically we have one entire circle that we could find the area of, and then we also have a parallelogram. Okay. So I'm going to find the area of the parallelogram first. So be careful with this right here. They don't make it super known. This 6 inches refers to the halfway between over there. So this is 6 inches, and this is also 6 inches, and together they form 12 inches, which would be the base. So I know my area of a parallelogram is just base times height. So this is 12, and then my height of my parallelogram is 5. So the area of my parallelogram is just 60 inches squared. Now, for my circle, since I have 2 halves, I can just find the area of a full circle. So this 6 inches right here represents the radius of the circle. So that's all I need to find the area. Just pi times 6 squared, which is approximately 113.1 inches squared. Now, as we've done before with the one above, to find the composite area, we add the 2 areas, or the multiple areas that the multiple areas of the shapes that are formed in the composite figure. So this area will just be 60 plus 113.1, which is equal to 173.1 inches squared. And with that, we're done with that one. Alright, so let's just kind of set up what shapes you'll be using to find the composite areas for the rest. This right here is obviously a triangle. This right here is a rectangle. And this right here, last shape of this composite figure, is a half circle. So use this to find what we need. And I believe we have enough information for that. If you have any questions on that one, of course, as always, please feel free to email me. Okay, next one. We have another half circle at the top. And then the bottom, of course, a triangle. Now some of these might make you work to find some of the side links, but I believe in you and I think you can do it. But of course, if you need help, go ahead and email me. Number 5. Oh, look, I've already written this one. This is a square, obviously. We have a trapezoid, and then 2 triangles. Or together they form one big triangle. Let's just talk about that. So, of course, like we've been doing, to find the area of this composite figure, you just take the areas of all the 3 shapes, add them up together. Okay. Now, a little bit different than areas of composite figures are what we call shaded regions. So, you might see a problem sometime that says find the area of a shaded region, and this is we're going to introduce what that means. So, like, if I have a triangle, and then I have a square inside that, or a rectangle inside this triangle, and just the parts where the square is not, or the rectangle isn't, are shaded. And we want to find the area of this shaded region. What you would do is you would find the area of the triangle first. And since the triangle is bigger than the square or the rectangle, you then find the area of the rectangle, and you subtract the area of the triangle minus the area of the rectangle. And whatever's left over, once you do that, is the area of the shaded region. So, like we say right here, to find the area of a shaded region, first find the area of the entire region, then subtract the area of the non-shaded regions. So think of it this way. If I have a piece of paper that is an 8 by 11, it means it has 88 inches square. But then I cut a circle out from the middle. It means it basically has a hole in there. So the area is no longer 88 square inches. It is 88 square inches minus whatever that area of that circle was in there. Because we're pulling something out where that part is missing in there, so we cannot account for that when we take the area. Okay? Alright, let's do some examples. So, if we look at what we have here, I have this square, it looks like, and then I have this circle that was just cut out the middle of the square. Okay? And the only thing I'm given is that this side is 25 feet. But since it's a square, I know that every other side is 25 feet as well. Okay. Ooh, that looks bad. Okay. Well, I also know, I see that the edge of the square is, or the circle reaches from one edge of the square to the other edge of the square, and that line would go through the center. Remember, this line is what we call the diameter, so this is also 25 feet. But remember, I need to find the area of the circle somehow, and I find area in terms of the radius. So, to find the radius of the circle, we divide 25 divided by 2, and we get that this is 12.5 feet. So let's find the area of our circle. That's equal to pi times 12.5 squared, and that's 490.87 feet squared. Okay, so we found the area of the hole that we cut out of this square. Now, to find the shaded region, let's go ahead and find this area, the whole entire thing first, which is the square. So a sub square, or s, is equal to the side squared. That's how it's the area of a square formula. So this will be 25 squared, which is 625 feet squared. Okay, so now we'll find our area of our shaded region, which is just the area of the square minus the area of the circle for a total area of the shaded region to be 134.13 feet squared. Okay. Alright, let's see which one I want to do for you next. I'm going to do, I'll do 7 and 8 for you, let's see. Number 7, our outside figure. For this time, I'm going to go ahead and label what that is, outside. That is a rectangle. And then the hole that's on the inside is a triangle. So I know I'm going to be finding the area of a rectangle and the area of a triangle. Let's go ahead and find the area of that rectangle. First, the rectangle has length 25 centimeters, width 14 centimeters. So the area of our rectangle is equal to 14 times 25, which gives me 350 centimeters square. Now to find the area of the triangle, I need a base and I need a height. This is my height of 11 centimeters. My base is just equal to 25 centimeters. So my area of my triangle is 1/2 times the base of 25 times the height of 11, which gives me 137.5 centimeters squared. Okay, so now that I have this, I can find the area of the shaded region. Well, really when you're doing this, once you found the areas of your two shapes, you can obviously tell which one's going to be subtracting from the other. You're always going to take the bigger area minus the smaller one. So our area is equal to this area of the rectangle, which is 350 centimeters squared, minus the area of the triangle, which is 137.5, to give me an area of the shaded region to be 212.5 centimeters squared. Alright, let's do number 8 together. This looks a little bit more difficult. So, let's first off see what kind of shapes we have. Of course, I have our outside one is a half circle. That's going to be the bigger area. And our smaller one on the inside is a triangle. And a right triangle at that. And that's important because we'll be using that to find some of our side lengths that aren't given. So if we look at this, to find the area of the circle, I know I need the radius, which would be this portion right here. Okay. So if I found the whole entire thing, which is the diameter, I can then know what the radius was, right? But is there any way I could find this length right here? And that's where the fact that our triangle here is a right triangle comes in. Since from this right triangle, I have two sides of the right triangle, the two legs. I know how to find the third side of a right triangle if I'm given two sides. It's something called the Pythagorean theorem. We know this. So this is the hypotenuse of the right triangle. I'll call it C. So C squared is just equal to the 9 squared, which is one of the legs, plus the other leg squared. So 9 squared plus 21.6 squared. This gives me that C squared is equal to 547.56, and then x squared, C comes to be 23.4 meters. Alright, so now I have my radius of my circle, my diameter, So the radius is just 23.4 divided by 2, which is 11.7 meters. Alright, so to find that area of the triangle, that's just pi times 11.7 squared, which is 215.03, and of course meters squared. And that is actually supposed to go over here. Excuse me. That's not the area of the triangle, that's the area of the half circle. Alright, yes, we found the area of the half circle. Excuse me. Now the area of the triangle, that's the area is 1/2 times the base times the height. The base being 9 meters, the height being 21.6 meters. Plugging this into my calculator, I get the area of the triangle to be 97.2 meters squared. Okay, now find our area of our shaded region by just doing the area of the half circle, which is 215.03. Oh, will you excuse me? I noticed a mistake that I didn't do. And that's a very easy mistake to make. Let's try to figure out what I did. So, I found the area of the entire circle, but this is not an entire circle. This is not a whole circle. It's a half of a circle. So, what I'm going to do, I'm going to divide my circle by 2. My area of my circle divided by 2, and that gives me the area of the half circle to be I looked at my key wrong. It is 215.03, but I didn't. This would have been divided by 2, which still gives me 215.03. Sorry about that, but that is the area of our half circle. So pi times 11.7 squared divided by 2 gives me 215.03. Okay? Alright, now that we're on the right track, I have my area now, which is this 215.03 minus the 97.2. So my area is 117.83. That's meters squared. So see, when you're doing these, you have to be careful. It's not necessarily super hard, just easy to make a careless mistake like I did, okay? Just be very, very careful. Number 9, I think you can figure this one out. This is a trapezoid. And again, half circle. Okay? And with that, that concludes the video. Sorry about this video not being up the first time, or the audio not working, so hopefully now you may be able to finish the homework and everything, the notes I've been giving you. So, if you go ahead and look at the area of composite figures homework, the shapes look substantially different than what we went over. So, of course, as always, if you have any questions, feel free to email me. Turn these in on Blackboard or on the form that I sent out, and I would be more than happy to check them for you. And from there, I'm going to call the video today. I hope everyone's having a great quarantine. I know we're almost done with when school would end, and I wish we would have gone back to school so I could have said hey to all y'all, and wish we could have said goodbye and all that. But, you know, things happen, so we're going to make the best of it, and that's why we're doing all these videos right here. So I hope everyone has a great remainder of quarantine, and I'll see you in the next video. Thank you guys.